Okay, so we're going to go over chapter 4. It's all right here. So first thing I want to start with is open and closed systems. Open system is transferred from system, or transfers, I don't know if it's transferred energy, but we'll say transferred from system and surroundings. Examples, a stove and a pan without a lid, because heat's going everywhere, or like an oven where you open it up, all the heat comes out. A closed system is heat cannot escape. Example, a pan with the lid on it, so like a stove where you put a lid on it where it's like boiling water and the heat can't escape. Next thing we're going to talk about is how to find change in mass. The first thing is it's a calculation of change in mass divided by initial mass. The beaker example, we did this in class. It's where you put something in you put your starting object in the beaker, then you get the mass of it, you take it out, you put the other object in, and you get the mass of that one, you subtract the first one to the next one, and you can just use it from that. Next thing is heat. Infrared radiation. They have longer wavelengths than the visible light humans can see, but shorter than radio waves. So here is an example of it. This is my example. So here it's still visible to a human. Here, or like right here, is infrared. Here is microwaves, and then this whole right here is all radio waves. Next thing we're going to talk about is renewable and non-renewable resources. Renewable resources, they're basically resources that are unlimited, which is like wind and solar. Pros, they're unlimited and they're reliable. Some cons, they're high development, which means they're really expensive, not able, in some areas like wind, like say you're in a place where it's not really windy at all. High development means like solar panels, like I say that, because they're super expensive. Non-renewable, they're used up quicker, so they don't last as long. They cannot be replaced. Oil and natural gases, some pros are that are inexpensive, and you can actually make them. Some cons is their pollution, and they're very limited. Then we're over to this one, which is phase change. This one is liquid to solid, which is basically freezing, and vice versa, from solid to liquid, which is heat. Okay, so this is going to be some of chapter 5. So chemical reaction, it's change in color and temperature change. Here's 2 examples. It's Coke reacts with oxygen in the air. The other one is baking soda reacts with vinegar in a bottle to produce carbon dioxide, stuff that you usually breathe out. Melting point, I didn't really want to put both, so I just made it shorter. Liquid turns into gas is boiling point. Melting point is, there we go, temperature into a solid to a gas. Example, so say melting point was 660.3 and the boiling point was 2519. It would be aluminum because you just look for it on the scale. Next thing is exothermic, which is heat energy transfers out of the system. Example, dynamite, it explodes. Endothermic, reaction absorbs energy. Example, battery to a bulb. Here's the energy diagram. That's the source. You got energy transfer, and then that's the receiver. Okay, and then here's I think it's acid, neutral, and bases. So acid would be like car acid. You do not eat that because you're not supposed to. And lemon juice. And next thing is neutrals. It's milk and seawater. And base is drain cleaner and oven cleaner. Okay, now come with me. So it's right here. It's on page 491. You have your pH scale. So say you eat something like, I don't know, you have some type of stomach problems here. You want to eat something like over here, like you don't want to eat like none of these. Like these 4 down here you don't eat. So like this would help you, like milk of meat. I don't know how to say it. That's hard to say. You can drink that. It'll make your things come down more, so it'll be like kind of more neutral. And like you can drink milk that'll drain out the stuff. So that's how you bring your pH stuff back down. So yeah. So
thanks.
this is chapter 5, continue. So we got 5 through 7 here. So we're going to start with elements. They cannot be split into simpler substances, which is an example of which is oxygen. You can't really split it up because it's already one thing. Next thing is compounds. Elements need to be combined to make them. So example, water, or you can do like H2O because there's 2 elements. See right here, H and O. You got the 2 in the middle because you need 2 oxygen or 2 whatever. Then we're going to go to metals, nonmetals, and metalloids. They're silver gray. Metals are silver gray. They're very high melting point, but they have high density. They're shiny and they're really good conductors. Next thing is nonmetals. Their colors vary. Low melting point, low densities. They're very dull. They are not conductors. Example for metals is copper, by the way. Example for this one is oxygen. Metalloids, their colors vary, so the same thing as nonmetals. They vary through both for these 2 right here, so high and low, depending on which one you have. These 2, so they can be both. This one can be shiny and dull, and these are semiconductors, so they swap between these 2. So this and this. Next thing we're going to talk about is by the way, the example for metalloids is, I think, silicon. It sounds like silicone, but it's fine. It's not. Next thing we're going to talk about is the periodic table, which is right. This is not behind me, but that's one of them. It's found by Dimitri. I don't know how to say his last name. I think it's like Mendembly. It's close enough. It was 1869 when he found that out. We're going to talk. Next thing is the 2 elements are liquids at 2 elements that are liquid at room temperature. Mercury and I think that's bromine, something like that. So nonmetals are on the right side of the table, and metals on the left side. Here's an example of one of them. Don't worry about any of this here. This is what it would look like. This is an actual metal. And if we go over to the periodic table, which is right here in the book, it's the very last page. You've got all the blues here. Just don't worry about these on the bottom. So you've got all the blues, which are metals. So scandium is right there, if you wanted to know. Metalloids are all the greens, which is here. Those are metalloids. The yellows, which are these and up, those are nonmetals. Here are noble gases, and the last 2 rows down here are rare earth metals. So hope you liked it. So here we go. We got you got all your little numbers here, which has got all 3 of them, which should be right here. They're all correct. Well, you got this one, and this one. That's a Z. That's not a 2. So that should be long enough. So now we've got this problem, which is calculate your best value, calculate uncertainty, whether something is increasing, decreasing, or staying the same. You've got all your times, your temperatures all right here. And you come over here on my spreadsheet, which I got here. You got all your times, your temperature. You're dividing 1. You got your best value. Well, no, so yes, best value. 1142.4 divided by 21, which is counting that one. And that's to make 54.4. Your uncertainty, highest value minus lowest value divided by 2 will give you that. Because you're doing 105.4 minus 1, which will give you 104.4. Dividing by 2, it's increasing. The graph is right down here. So you got increasing here. It's right here. Yeah, it's not tech. It's as straight as I can get it. And you got your reasoning here because you got your 54 here is your best value, which is higher than your uncertainty. So hopefully you liked it. Thanks.